trying to, I'm really just trying to motivate you guys to be really excited about the opportunities that exist in ocean drilling programs. And so the title is Accessing and Harnessing the Data from the International Ocean Discovery Program Archives. And these are just some photographs from the past of people, the ship, the Headwaters Resolution, and people sailing for scientific cruises. And the scientific ocean drilling history is really long. The initial phase was called Project Moho. They were trying to drill to the Moho. That's 1958 to 1966. And then it's had several iterations. They're basically the funding goes usually in something like 10-year blocks. And so they put out calls for new competitions every 10 years or so. And the latest version of this program, run out of the Texas A&M University in College Station, has started in 2000. Actually, it ended up starting in 2014, and it's going to be extended to 2024. And then there's the hope that there will be a chance of extending the life of the drilling with the Headwaters Resolution to 2028. But then the ship will be 50 years old and they won't extend it anymore. And so the U.S. National Science Foundation is actively working on what is going to be the next steps. One possibility is no more ocean drilling. We hope that's not the case. The most exciting possibility is that they're going to build a new ship to continue ocean drilling. But there's going to be a gap in the sort of usual way of doing things. Right now, the sort of flagship ship is the Headwaters Resolution. It's operated out of the United States, and it's a riserless platform. It's able to drill I don't know what the shallowest is. Maybe you're on the order of 400-meter water depth, but to the deepest depth in the ocean. And then there's a Japanese ship that's relatively new that has a riser platform. So they typically stay in relatively close to the shore areas. And then the IODP also participates in mission-specific platforms. Most of those are actually run out of Europe. And the platform is chosen based on what the objective is and what's required to achieve the objective. So there's a number of vessels in addition to the Headwaters Resolution, but the Headwaters Resolution is by far the sort of workhorse of the ocean drilling program. So here's just a video of a operation of bringing a core up onto deck on the Headwaters Resolution. This is actually on the cruise that I sailed on that I'm going to be giving some background on during this lecture. So you can see there they have a big long pipe up on the rig floor, and they're pulling out a liner from that pipe. The length of that core is 10 meters, and so they pull out the liner. This is the rig crew, and they hand it over to the IODP technical staff, who take it onto the rig floor, not the rig floor, the working area for the scientists, and they measure it really carefully and cut it into approximately 1.5 meter sections. They measure everything carefully. They label everything carefully. You can imagine the requirements for keeping track of which way is up and what's the relative position of the sections of the cores that are being handled. So this is actually there I am over in the corner watching the techs put together the core. This is one of the early cores from our cruise. So there they are. They're working together to cut the 10-meter core into 1.5 meter sections, and then they're going to label those, cap them off really carefully, glue the caps on, and then take them into the room where we start making the measurements on the physical properties and sedimentological observations. And those sections get split longwise. So there's two halves, an archive half and a working half, and the archive half gets preserved without being sampled. Anyway, so again, I'm Sidney Hemming. I'm a professor in Columbia at the Department of Earth and Environmental Sciences and a researcher at Lamont Doherty Earth Observatory. And the cruise that I'm going to give you a little overview of is Expedition 361, where we collected cores towards the goal of getting a 5 million year record of the Greater Agulhas current system. So the Agulhas current is the strongest western boundary current in the southern hemisphere. It flows along the eastern coast of Africa until it gets to the end, and then it retroflects back into the Indian Ocean. And where it retroflects, rings and eddies are spun off into the Atlantic Ocean. And the Agulhas current is warm and salty, and so it's thought that the extra salt that's being brought into the Atlantic Ocean from the Agulhas current could be an important factor in controlling the formation of North Atlantic deep water. So this is from a review article from Arnold Gordon, a physical oceanographer at Columbia. The influence of the Agulhas system of currents and eddies around southern Africa extends far beyond that region, hence the special need for a better understanding of the complex phenomena involved. So here we go, the Agulhas current retroflecting, sending eddies into the Atlantic Ocean up through the North Brazil current, and then eventually up into the North Atlantic to bring extra salt into the North Atlantic. And here on a bigger scale, we can see that extension into the North Atlantic region, the formation of North Atlantic deep water, and then just remember the other main area of the formation of deep water in the Earth's ocean is around Antarctica. So we're interested in a number of factors trying to put together a holistic understanding of the records from the cores that we collected around Africa. And one of the aspects is to actually understand the climatology in the past. So Southern Africa today bridges climates of the low latitude tropical regime, intertropical convergence zone, or the extension of that on land, the Congolan air boundary, and the northern extension of the circumantarctic westerly belt. And the intertropical convergence zone and Congolan air boundary form the divide between easterly winds arriving from the Indian Ocean and westerly winds arriving from the Atlantic. And interannual variability linked with the Indian Ocean dipole and INSO modes also operate to control the climate conditions in Southern Africa. Sorry, I've got to find my. And the other aspect that all the people who were sailing on the cruise were really interested in is how this variation in climate in the past has linked to the evolution of humankind. And so this is just a graphic from a review paper from Peter Domenical, kind of putting into context the fossil evidence for human evolution and the marine record evidence for changing climate around Africa, and in addition the soil carbonate evidence for changing aridity in Africa. So the goals of our expedition 361 were to establish the sensitivity of the Agulhas current to changing climates of the Pleistocene in association with transient to long-term changes of high latitude climates, tropical heat budgets, and the monsoon system, to determine the dynamics of the Indian Atlantic Ocean gateway circulation during such climate changes in association with changing wind fields and migrating ocean fronts, to examine the connection between Agulhas leakage and ensuing buoyancy transfer and shifts of the Atlantic meridional overturning circulation during major ocean and climate reorganizations during at least the last 5 million years, and to address the impact of Agulhas variability on Southern Africa's terrestrial climates and notably rainfall patterns and river runoff. So this is the science crew that sailed on Expedition 361. Ian Hall and I were the co-chief scientists, and we sailed with Leah LeVay as the staff scientist and had an international group of scientists that covered all of the necessary shipboard measurements and observations to characterize the cores towards the goal of better understanding where to sample, how to continue the drilling, and how to get the best records from the sites. So I'm just going to quickly give a little bit of an overview of what we got from each of the cores that we sampled, that we took on the cruise. And so the first site that we occupied was 1474, and you can see that 1474 is over on the east side of Africa. It's basically where the Agulhas current, very close to the headwaters of the fully constituted Agulhas current. The sediment accumulation rate there was about 4 centimeters per 1,000 years. It had a good magnetic reversal stratigraphy and good agreement between the magnetic stratigraphy and the biostratigraphy timescales. We're in the process of generating a benthic isotope stratigraphy. We're going to actually be reporting on progress of that at the AGU meeting this fall. And this is an important location for characterizing the triginous detrital sediment supply into the Agulhas current, and with the goal of really understanding both changes in the Agulhas current and also rainfall on Africa. And my current PhD student, Danielle Babin, is working on this aspect. We had troubles gaining permission to drill in the Mozambique waters, and so we went south next and took a core site on the Agulhas Plateau. So in the early part of the Agulhas retroflection, and that was a really exciting site as well. I forgot to mention on the first one that we got back to about 6 million years. We also got back to about 6 million years at the Agulhas retroflection site. We have an early paper published by Jens Grüstner et al., where the shipboard stratigraphy and seismic surveys were connected, and the return to the Agulhas Plateau actually just happened earlier this year. They've now drilled many sites and gone back much older. They've gone back to the basement in the Agulhas Plateau. The sediment accumulation rate was really quite variable and appeared to be varying in response to climate changes. The benthic isotope stratigraphy is well underway, led by Ian Hall and his student Aidan Starr. And this is a site where there's a lot of opportunity for putting together really important observations related to how changes in ocean surface and deep ocean circulation, the movement of the fronts and wind migrations, and productivity associated with the boundaries there are connected with global climate changes. And so this is just a list of the scientific participants that are really interested in pulling together that part of the story. And then there is some iceberg rafted detritus on that at that site, even though it's really far north from Antarctica. And Ian's student Aidan Starr has been putting context on that ice rafted detritus at site 1475. And then we finally got Mozambique permissions. And so the next 3 sites were in Mozambique waters. And the first of those is 1476. 1476 had a slower accumulation rate of only about 1 or 2 centimeters per 1,000 years. Also went back to about 7 million years. The first published paper from the cruise was actually from 1476. One of the nanofossil paleontologists published a paper on the last 1 million years of the extinct genus Discoaster. This is a place where the PCO2 is in equilibrium between the ocean and the atmosphere. And so Kaoru Kuboto is working on boron isotopes to look at the carbon dioxide proxy from that record over time. It's also a place where the terrigenous sediments from Africa provide evidence for African aridity. And we have a paper that just came out this year led by Jeroen van der Lubbe that's published in Nature. We also have one of the sailing scientists, Melissa Burke, is working on organic biomarkers, and Margaret Simon and Ian Hall are working on understanding the thermocline changes associated with connections with the Indonesian through flow at this site. And then 1477 is off the Limpopo River, and it was amazing. So this is actually a graph that shows the age depth for each of the sites from the cruise. And so 1474 was 4 centimeters per 1,000 years. 1475, you see, has this big change centered around 4 million years. 1476 is a little lower slope, lower rate of accumulation than it's the lowest overall from the cruise. But 1477 has about 1 meter per 1,000 year accumulation rate. So this is a big surprise. We were expecting high on the order of 10 centimeters per 1,000 years, and we were hoping to get back to about 2 million years in order to really understand the changes in the drainage on Africa in the Limpopo drainage. There's been some changes in the river networks, and we wanted to capture that. But you can see that we really got a much shorter time scale. But this extraordinary sediment accumulation rate has benefits as well. So we can't get back to 2 million, but we have such a high accumulation rate that we have potential for connecting to millennial events in the North Atlantic. And there's a few people that are actually working on looking at carbon cycle changes and making these connections with the North Atlantic climate events. And this will also allow evaluation of source changes in the Zambezi catchment. And there's several of the scientists, including my PhD student, Daniel Babin, who are interested in working on those aspects of the core. In 1478 was off the Limpopo River, and there we also have a benthic isotope stratigraphy underway. And this is a place where the main target was to actually really look at the changes in African rainfall and river runoff with a variety of proxies, organic markers, pollen, and terrigenous tracers, and even the barium to calcium ratio as a proxy for freshwater runoff. And this is also the site where Thibaut Cayley was interested in using as a reference site for the faunal assemblage that represents the Agulhas through time. Okay, and then 1479 is back in South African waters. And before I actually say about what we found from 1479, I'm just going to give a little overview of our pre-existing studies in site RC 1183, which was the reason that I was actually involved in the cruise. So Steve Goldstein and I worked on this site for a number of years with several PhD students listed on the bottom there. And what we found at site RC 1183 is terrigenous sediment traces the Agulhas leakage. The Agulhas current carries sediments that come from older sources on the east side of Southern Africa. So the higher the strontium isotope composition, the more the Agulhas leakage. And you can see that there's a strong pattern of variability in the terrigenous strontium isotopes. The benthic carbon isotopes trace deep water circulation. So during interglacial times, the carbon isotope composition is higher compared to glacial times. And in addition to that, the orthogenic neodymium isotopes also trace North Atlantic deep water. And so we have two sort of complementary tracers of deep water and one tracer of surface ocean circulation. So 1479 is really ideally located. I don't have it on here, but the depth of 1479 is in the heart of North Atlantic deep water at this part of the ocean, and it's right in the place where the Agulhas rings are leaking into the Atlantic Ocean. So this is a site that many of the scientists on the cruise were really excited about because of that intersection at the gateway between the Indian and Atlantic Ocean. The benthic isotope stratigraphy is well underway. It's being led by Chris Charles and Thibaut Cayley. Alison Francis is working on the terrigenous detritus to trace the Agulhas leakage. In addition to that, Thibaut Cayley is looking at the Agulhas leakage fauna to try to trace the Agulhas leakage. And Chris Charles is looking at the nitrogen isotopes of foraminifera. There's a big contrast between Indian and Atlantic composition. So he's looking at that. So we have these 3 measures of surface water movements in the area. The Delta C13 traces deep water circulation. Sortable silt also traces the vigor of the deep water currents. And again, the orthogenic neodymium isotopes trace North Atlantic deep water. So we have multiple proxies for surface water and deep water there to try to understand how this fits into the global circulation. So in summary for that cruise, the IODP 361 obtained continuous records back to as much as 7 million years, and 5 million years in 4 of the 6, and 2 million, so 4 million years in the one off the Limpopo, and only 150,000 years in the really high accumulation rate, 1477. This expedition filled key gaps in Indian Ocean drilling, and continuing ongoing work from participating scientists it will lead to records of the Agulhas current, ocean overturning circulation, African climate, as well as relationships with global climate variability and human evolution. So 361 is located over here in the blue box, and it's the pink dots along here. That was our expedition. There's staffing now for expeditions 395 and 400. So we're, this was 2016. What I want to do for the rest of the lecture is to give both a sense of how you as a scientist could tap into all the data and archives that exist from the 50 years of ocean drilling, as well as to sort of highlight that there is another cruise that was drilled that has sites in the Gulf of Guinea. So Expedition 159 drilled several sites in the Gulf of Guinea. And it's important to realize that after a 1-year moratorium where the samples and data from the shipboard are available only to the science party, after that 1 year, all of the data and sample requests from the Corps are openly available for scientists all around the world. You don't have to be one of the countries that sailed on the cruise to request samples to study. And anybody can just go to the website and access the data that were generated during the cruise. And in addition to that, the IODP staff put a concerted effort into keeping up with the publications that are produced as a result of these cruises. And so there's a bibliography that gives you a start into the science behind the drilling that has been done. So, but there is a spin up. There's terminology to learn in order to convert the sample name that you might request to the depths in the site. And this is one of the things that I found to be a little bit of a barrier to getting started with IODP materials. But I have to say that there's a few things you need to know that allow you to really understand how to connect the information. And in addition to that, the curating staff at IODP is actually very helpful. So, if you're interested in tapping into this, it's really wide open and available, and it's an enormous resource of existing data, some of which has only been published in the sort of ship reports from the original expedition, and samples that can be taken from the working half of the cores and used for whatever kind of geological question you might have. So I'm just going to spend a couple of slides trying to go through how you get started accessing information from the IODP drilling. The site you would go to is www.iodp.org. And so if you type that in, this is what you get, the picture that we see in front of me. And what you want to go to is resources. And under resources, you can explore this site. There are many things to look at, but I'm trying to take you surgically to how to get to data and samples. So access data and samples, select that. And then there are a number of sites that are related to the different programs that I mentioned earlier. So the CHICU would be under this site, but for the JOIDES resolution sites, you go to this first website, iodp.tamu.edu, and there you get a list of all the sites that are represented by ocean drilling. So starting, this now it's International Ocean Discovery Program, and that's IODP 349 onwards. But all of the previous iterations of the ocean drilling are also represented on here. And so you can see that these are the expedition numbers along the top gray bar here. And the information that you can tap into from this site are listed along the left-hand side. And so I'm going to use the expedition that drilled in the Gulf of Guinea to sort of, go through an example from this. And so that was during the ODP, which is between 101 and 210, it was Expedition 159. And Expedition 159 drilled 5 sites. And the site that Sarah Nicholas mentioned, and we're very excited about working on, is actually site 959. So the sort of surgical strategy for tapping into what information, what records, what cores are available from the sites is this row called core section summary sections. And if you select core section summary, and then I actually skipped a step in terms of capturing the screen. You have to actually go in and select Expedition 159, site 959 to get to where I am here. And then when you get there, this is the core section summary for, they called them legs, and that's instead of expeditions, leg 159, site 959, hole A. Okay, so core 1, this is the type of core. So H, I don't know why H stands for piston core, but this is the advanced piston core. Section 1, remember the core, in this case, the core catcher is the bottom. In this case, the top of the core was 8.82 meters, and this is 0.626. So the bottom of the core is about 9.1 meters in total, and that was cut up into 1.5 meter increments, right? So these are the section 1, 2, 3, 4, and 5 were all cut into 1.5 meter increments, and then 6, there was only 1.32 left. And then the core catcher is at the very bottom, and they basically cut it off when they first bring the core up, and then they isolate that separately. In this case, it's 26 centimeters long. So this is the way to understand where things are. And below here, so this is all shows up as hole A. So core 1, sections 1 through 6, and then core catcher, core 2. Sorry, I've lost my cursor. Core 2, sections 1 through 7, and then core catcher, core 3, sections 1 through 7, and then core catcher 4, and so forth. And then below that would be hole B, and then if there was a third hole, C, and so forth. And this site, I believe, did have 3 holes drilled. And the reason for that is because one of the really big goals for paleo oceanography is to get a continuous record of environmental variability. And in between each of these cores, and the way they're taken, I showed the video at the beginning of one core, then after the one core would be taken, the drillers would go down, clean out the hole, and then drop a second piston core, and then bring that up and eventually continue down. And the depth at which we can usually go with this advanced piston coring is somewhere between 200 and 300 meters in general. You just keep going down and creating a deeper and deeper hole and taking the core out of it. But in between each one of these cores, and at the top and bottom of each of these cores, there's room for mischief. You can maybe you've disturbed the sediment, maybe you've mixed in some sediment from below or above, and so maybe it sort of flowed, and so the tops and bottoms of each of these cores has some intervals that are somewhat suspect, and so the triple APC coring takes basically attempts to take cores so that the boundary between the core B would be maybe the top would be between section 3 and section 4 of hole A, so that there's a messy interval, but the messy intervals are not the same in the different holes that are being drilled. And these holes are about 20 meters apart. There could be some very natural variation that you're not able to overcome with that. But in general, you're able to make really good correlations between the cores and end up with a synthetic splice that is a continuous record of environmental variability. So just to sort of test our understanding, what would be the meters below sea floor for a sample from 159, site 959A, core 1, section 2, 25 to 26 centimeters? I'll put my thing up so I can see if anybody's raised. Raise your hand if you can answer that, if you want to answer that question. Oh, there's not like a whole group of people I'm having to choose between here or anything. So, okay, I'll just move on and actually answer that question. But, at least for me, when I'm in a class, even if I'm uncomfortable answering the question, it kind of sharpens my appreciation for the answer to the question. So hopefully that'll be true for you as well. So the answer is that here it is, 159A, 959A, 1H2, and that section is 1.5 meters long. The top of that core starts at 1.5 meters because the section above it was 1.5 meters, right? And so the sample is at 25 centimeters in that core, and so the depth of the sample is 1.5 plus 0.25 or 1.75 meters in that hole. Okay, so as I mentioned, this expedition 159 was drilled in the Gulf of Guinea, and this is the sites that were drilled in the Gulf of Guinea: 959, 960, 961, and 962, with the latitudes and longitudes and water depths for these sites. And they were drilled off this ridge off the Ghanaian shelf, and the main expedition objective for this expedition was to understand the sort of tectonic history associated with the opening of this part of the Atlantic. So the sites were the targets. They penetrated through marine sediments, which is the topic that I'm particularly interested in, is the paleoceanographic or paleoenvironmental record. But their goal was to get deeper and actually understand the structural evolution of this margin. So these sites go back, in some cases they go back to the basement in the region. So if you're somebody who would be more interested in that stuff, all that information is available on the IODP website. You can explore looking at the information from the cores themselves, and the reports from the crews are also available on the website. And publications that came from that are curated on the IODP pages as well. So my interest in 959 and the reason I became aware of your summer school is because I'm an argon geochronologist, and I have become really interested. I have like a multitude of projects that I'd be excited to use the potassium argon dating of glauconite to study. And this started because I was using a reference standard called GLO1 glauconite that had been produced by the person who almost undoubtedly has put the most effort in the world into the mineral glauconite, Gilles Odin. And one of his papers was about the occurrence of modern glaucony in the Gulf of Guinea. And he had actually done some potassium argon measurements to look at the processes of forming glauconite and the time scale of forming glauconite. And I was really, back in the day, this paper was published in 1982, he had to use much, like 50 milligram or even bigger samples in order to do his studies. But he made some really incredible advances in our understanding of the processes of forming glaucony. He had done X-ray diffraction, lots of geochemical measurements, potassium argon measurements. He examined in great detail under a microscope and with scanning electron microscopy and so forth. Really worked hard to really understand the processes of forming glaucony. But nowadays, instead of having to use 50 milligrams, we can use 50 micrograms. We can get to the single pellet scale and examine these. And I think Sarah will talk a little bit in the next lecture about the kinds of technology that are available with the synchrotron light sources. But we have the potential for really getting the same sort of beautiful data that Odin was able to get on big samples on single pellets. And so I was really excited about the Gulf of Guinea. And then Brian Arbit gave a presentation about your summer school. And I just went because I knew Brian, but I went Zoom. When I say when, I went by Zoom. And he was talking about this summer school, and I wrote him a private chat and said, I'm really excited about this, and I'm really excited about finding a way to get involved in the marine geology part and studying glauconite in the Gulf of Guinea. And so that one thing led to the other, and we now have a proposal underway to try to get drilling going on there. Anyway, I just found, as preparing this presentation, I just found this really new paper by Pierre Giresi, who's one of the people who worked with Odin to look at the modern glaucony in the Gulf of Guinea. And this is is really kind of an intriguing process that is proposed for the formation of glaucony. They're little pellets. They typically look like either they form in the inside of a shell of forams, and so they look like forams, or they replace pellets, fecal pellets, or in some cases they just replace grains of whatever composition. They're just really weird little organisms, not organisms, weird little features. And the people that have studied them feel strongly that they're forming right at the sediment water interface, and there must be iron. There's a redox story going on. There must be iron coming from the sediments, and they feel like that the potassium is coming from the water column. And then there's an evolution that's been sort of observed as a result of careful microscopy studies, an evolution in the maturity of the glauconite. So ODP site 959 has been demonstrated. Giresi was one of the authors that demonstrated the presence of near zero age glaucony at site 959. And several studies, beginning with the Odin study I was mentioning, have demonstrated that glauconite is forming in many of the shelf locations around the Gulf of Guinea margin. And so we have a proposal that's under consideration. I mean, it seems promising if we can work out the logistical aspects that would bring together U.S. and West African scientists to take new samples and study in detail the sediments along the Gulf of Guinea margin in several transects. And if we can manage to do this, this would be, we think this would be a great hands-on topic for the summer school for the next few years, if we can get the funding to pull this off. And so I'll end with that. And let's see. Stop share and see if there's any questions or comments. Oh, okay. Got something from Brian saying we have online lectures and in-person activities happening simultaneously. So he's going to leave it. Okay. That was a while ago. Anyway, are there any sort of questions or discussion points that y'all might have? I realized as I kind of rushed through that one thing that I didn't do very, except for showing the little cartoon, was to say what glauconite actually is. So glauconite is essentially an iron illite mineral. It's a clay mineral, and it's thought to, it basically from the observation of where it's found, it looks like it's mainly formed in shelf environments, and it's mainly formed when the rate of accumulation of sediments is relatively low. And it's typically where you find it is where you have a sea level drop and then rise. So the transgressive surface from the sea level rise seems to be where the glauconite pellets get concentrated. So it has an intriguing relationship to the sort of physical stratigraphy of the sediments. But it's not quite as simple as that's where it's concentrated. But site 959 is in 2,000 meter water depth. So it's not only forming on the shelf, it's also forming in deeper waters. And the exact processes that it's forming, we're really intrigued to know. And about that, that expedition that we're hoping that we're going to get funded to do, we recognize that not everybody is interested in glauconite. In fact, I would even say that not everybody on the proposal is interested in glauconite. I'm particularly interested in glauconite, but we're interested in the environmental variability that leads to the formation of glauconite. We also will be, by getting these detailed transects, we will have samples to look at the faunal, the benthic fauna in the area, and also even for the core top samples, maybe even to see human impacts on the environment in the shelf areas of the Gulf of Guinea. So what information does glauconite give us about the sediment? So glauconite is an orthogenic, it's a diagenetic mineral, and that's a really good question, what information it'll give us about the sediment. But the presence of glauconite requires some kind of special conditions. In order to free the iron to form in the glauconite, there must be some reducing conditions going on. And typically where there's glauconite, we're also finding a lot of pyrite, so indicating reducing condition. Glauconite is very potassium rich, much more potassium rich than the sediment that it's replacing. And so that means that we have to have some kind of microenvironment where we're able to bring in potassium from the ocean, from seawater, and bring in iron from the sediments to sort of reconstitute this sediment into these new pellets. And so actually, Urias, I think that the answer is we want to know that too. That's exactly the question we're trying to tackle with our project. Do you study benthic organisms like foraminifera in the core samples? So not I particularly. I think I can recognize benthic from planktic forams now, but I would not claim to be a paleontologist. But we do have people, Ingrid Hindi and her student, Madeline Cook, who might even be, is she in Nigeria?
No, she's not involved this year, unfortunately. She's
okay. Yeah, she's
finishing
really
her thesis.
She's in her last year, and so she's very busy. But anyway, Ingrid Hindi and Madeline Cook are both experts in recognizing the benthic foraminifera, and it's one of the things that we would like to include in the summer school if we're able to get this off the ground. Would be training students to recognize the species in the sediment samples. So I'm not sure exactly what Sarah, I'm really sad to be missing Sarah's presentation actually, because I'm going to the airport, but Sarah is going to be talking about some of the approaches, some of the technology that has developed from the synchrotron light source that enables examining these pellets and other aspects of marine sediments in much greater detail than even 10 years ago. This is really kind of exciting emerging opportunities. And I know that there's at least some effort underfoot for Africa to build a light source there. So that's something that seems like it'd be a really exciting place to kind of connect on research fronts. Oh, good. So Victoria looked at benthic foraminifera from shallow core. So I don't know whether you're participating multiple times or not, but that would be very welcome. I mean, that our real goal, and I feel like it's so hard to actually get to know people from another continent just because of the great distances and the sort of the different circles we all go in. But I think that if you were available and willing to help out with training on that, that would be an awesome connection.
Thank you very much. I really appreciate it. There's no one that did not read.
Okay, well, if there are not other questions, I might leave you and go get ready for my shuttle to the airport. I really appreciate your attention, and I think I'm on Slack now. But if I'm not, and you need my email or something, I know that the leaders have my email address as well, and I'm really happy to engage with anybody about further discussions about the possibilities of combined collective studies on sediments from the Gulf of Guinea.
Awesome. Thank you. Yeah, I just checked. I see you on Slack now. So
Okay, good.
Great way to
Excellent.
chat this week some more. Yeah.
All right. Thank you all very much. And honestly, really check out the IODP site if you have an interest in marine geology, because it's incredible how much, you have to spend some time to get, to find it, but it's incredible. They really want people to use it. So, you just feel welcome to jump in and take as much information off that website as you can, as you're interested in.
Yeah, that's
Okay.
awesome.
Thank you all very much.
That.
Yeah, it's really incredible. All right. Take care, everybody.